Hi there everybody, today we are going to be looking at graphing inequality. So we're going to start off by just looking at graphing one inequality, and then we're going to move on to looking at graphing more than one inequality on a particular graph. Okay, so you'll see this coming up in GCSE examinations, but before we kind of move into this, it's really important that you already know what an inequality is, first of all, and second of all, you already know how to draw straight line graphs, because essentially that's what we needed to do this particular bit. You need to know what an inequality is, and you need to be able to draw a straight line graph. So if you haven't done those yet, then please go have a look at those two lessons first of all. But if you have, let's get going. So an inequality on a graph. All right, so first things first is that when we're plotting inequality, we're just going to start by sketching a line. Okay, now inequality, there's different inequalities. There's greater than, there's less than, there's greater than or equal to, and there's less than or equal to. So they're the bits that are kind of going to differ in just drawing a straight line. Okay, so we're going to just kind of think about, first of all, greater than or equal to or less than or equal to, because those little things will dictate what type of line we're going to draw. Okay, and what I mean by that is that if you've got an inequality that has an equal bit to it, so greater than or equal to, or less than or equal to, i.e. the little line underneath, your little crocodile shape, then your line must be solid. All right, so it must be a solid line that you're going to draw. If the inequality does not have an equal bit, so literally less than or greater than, then it's going to be a dashed line, and you'll see that as we go through some examples as we progress. And then the other part of it is that in order to represent an inequality, it's not just one number, so we're probably going to be shading a particular area on the graph which represents those inequalities, which you'll see as we go through this next example. So we're going to shade the region which represents y is greater than 2. So the first thing is, here we're looking at greater than 2, so we know this is going to be a dashed line, but we are going to plot the line of y equals 2. Okay, so we're going to draw the line y equals 2. Well, y equals 2 is a horizontal line which has a height of 2, so we find the 2 on the y-axis and we draw a horizontal line straight across there, all right, because all the y coordinates are 2 on that particular straight line along there, all right, and remember it's going to be dashed because it's just greater than. Okay, so that's the first bit. We've got the line, okay, which represents y equals 2, but it's dashed. The next bit, and it said in the question, shade the region. Okay, so what we're trying to do is identify which area, either this section or section which is y is greater than 2. Now, you might know that straight off, and that's absolutely fine, but I'm going to show you where, just to be sure that you've got the right particular section, and that's essentially fine. Pick a coordinate and see if it meets the criteria. So if I put a coordinate in here, okay, so we'll start with this one, where this coordinate is 1, 4, okay, so 1, 4, and if I think about a coordinate having an x and a y value, it's the y value I'm focused on, and you can see here y equals 4. So if I substitute that into this as my y, what we're saying is 4 greater than 2. Well, yeah, it is. 4 is greater than 2, so this coordinate is in the correct section. Okay, so that means that this area at the top is the one I want to shade. So a couple of ways of indicating that one is we can put a little kind of hash sign to say that it's not that bit, and then we look to shade the section which it suggests we do. Now this little like dashes to show you've rejected it is familiar. Just be very, very careful that it doesn't look like shading, okay, because obviously the key part of this is just shade the region. All right, so by all means kind of do it to identify that we're rejecting that little bit, but ultimately you must make sure that this bit here is clearly shaded as the question has asked us to do. Okay, so that's the first one. So let's look at another one. So in this case, it's asked us to shade the region of x is less than or equal to 3. Well, the key bit here, you notice it's got this little line underneath. It's or equal to, so that means our line is going to be a solid one. Well, the line x is equal to 3, which is the one I'm now going to plot. This is my x-axis. This is the value of 3, so it's going to be a vertical line up here. So that line would represent x equals 3. So there we've got. Now, if I just follow the same example as I did a minute ago, I'm going to choose a side or a coordinate. So let's see what it chooses. So we've got one over here. All right. So if I choose this particular one, Get my cursor over here, there. You've got 4, 2. All right, so 4 and 2. So if I just write that down, I'm looking at this time the x value. So this is the 4. So I'm going to substitute it into here. And when we say, is 4 less than 3? No, absolutely not. So it's not in the correct section. So we can eliminate that section because it's in the wrong place, and we can shade the other side because that bit must be less than or equal to 3. Okay, so 2 examples there showing you one where you've got a vertical line and one where you've got a horizontal line. But of course, when you look at drawing straight lines, you'll notice that they're not always horizontal or vertical. Sometimes we get a diagonal type of line. So we need to be able to plot straight lines no matter how they look. So here we go. And this is where the putting a coordinate in probably helps you a little bit, so to make sure that you've got it in the right place. So we're going to sketch the line of y equals x plus 2. And I should ask you, is it dashed or dotted? Dashed or dotted, that makes no sense. Is it dashed or solid? Well, here looking, it's got no line underneath it. It's going to be a dashed line. I'm going to plot the line of y equals x plus 2. So if I think about y equals mx plus c, it's got a gradient of 1. It crosses at 2, so it's going to be 2 there, and it's going to go 1, 1, 1. It's going to go 1 across, 1 up, isn't it? So it should go along there, like that. There we go. And then, again, let's just follow the same pattern. We might as well stick a coordinate in some side over here, and let's have a look. So we've got a coordinate which is along the corridor 1 and up 4. All right, so 1, 4. And again, we're going to substitute the value of y in. So y in this case is 4. So is 4. In fact, we're going to put both numbers in, aren't we? We're going to put 4 there and 1 there. So is 4 greater than 1 plus 2? Is 4 greater than 3? Absolutely. So it's in the correct section. So we're going to eliminate the bottom half, or the bottom bit, and we're going to shade the bit where the coordinate is placed. Okay. So that's one line. And that's absolutely fine. You know, I'm sure you want to go away and practice some of those. Please do. But we're going to look at one where it asks you to shade a region where it satisfies more than one inequality. Well, the process is exactly the same. We've just got to do it twice in this particular case. And it might be that you have one that's 3, 3, 3, basically on the same graph. But again, same kind of thing. We're just going to plot all of them first and then see what happens. So if I shade the region where x is less than or equal to 5, so let's draw the line x equals 5 first along. So find x on the x coordinate, and it's going to be vertical, so it's going to be over there, and it's a solid line because it's all equal to. We're then going to draw the other line. Always done in this particular case, it's actually, we're going to see which side of it is right, so we can eliminate the bit that's not. So what it's doing over here. So I would do it at the end, but this is absolutely fine. We can do it here. So let's look at this coordinate. You've got 2 and 1. So substitute the value of x into here. Is 2 less than or equal to 5? Yes, it is. So we can eliminate this bit on the right-hand side. Okay, so we eliminate that. That means it's somewhere over here. We're going to then do the next line. So y is equal to x. Well, that's not the diagonal one, so it goes through 0. It's all right. So positive gradient goes through there. And of course it's a dotted line because it's just less than. And then similarly, we're going to pick a coordinate over here. So it's got 1 and 2. So when we put those into the equation, we've got 1 on this side, which is the x, and the 2. Is 2 less than 1? No. So that's in the wrong section, so we can eliminate that section. So what you've done, you've eliminated 2 sides of it, and you're left with this portion in the middle, which is the area that we are now going to shade. And that's the region that satisfies both those 2 inequalities. Okay, so certainly a lot more work to do when you've got more than one inequalities, but the process is very, very much the same. You're just having to repeat it on the same graph, and as a result, you're going to get some kind of shape in there. In this case, obviously, you've got a triangle which represents those 2 inequalities. All right, so go away, practice. Please do practice this particular one. It's good for practicing drawing straight lines. It's good for obviously checking your inequalities and understanding. And of course, the more you practice, the better you get. Thanks for listening.